Hello, my friends. To, in this video, I'm going to demonstrate to you how to derive the magnetic field due to a conducting ring. And if my memory serves you, if my memory serves you well, we have done something similar when we go over, when we went over the MPS law. So today we are going to use different approach. We are going to use Biot-Savart law to, to work this out. Suppose you have a metal ring, a conducting ring, and suppose you have a current running in the conducting ring, and this current uh, is I, and in this little wire segment, the length is delta L. And by MPS law, when you have a wire, right? I've shown this one wire segment is a long one, right? Then we can apply MPS law, the right hand screw rule, to determine the direction of this magnetic field. Uh, So right now, right, if you use the right hand screw rule, then you will find that the magnetic field is pointing inwards, pointing into the right box. So in this case, you have a magnetic field here. And the magnetic field due to this little wire segments is dB. Now let's assume the radius of this ring is say 8. So uh, the distance here is 8. And the direction of the magnetic field should be orthogonal to the direction of this DL. By Bios, Bios-Savart law, the the delta magnetic field is given by mu I, where I is the current, and then 4 pi, and then dl sine theta, where theta is the angle uh, between dl, delta L, and uh, this radius. So from here, according to our interpretation, the this little y segment delta L is always tangential to this conducting ring. So the angle here is always 90 degrees. As long as the delta L is tangential, then it should be 90 degrees. So theta is 90 degrees in this case. So if it is the case, then sine 90 degrees will be equals to 1. So we have 90 degrees here. So the next line is going to be mu I 4 pi uh, and then dl over a square. Now, this is just the amount, the delta amount of magnetic field. And this magnetic field is contributed by this delta L. And if we want to find the total magnetic field due to the contribution around this circumference, so we have to calculate the sum for the whole circumference. The easiest thing that you can do is B is equal to delta B, integration, integral of B. And in this case, we have already worked this out. Uh, the integral of B is equal to the integral of this expression. And then dl. And the integral should run from 0 and the whole length of the circumference. The whole length should be 2 pi a. So if you do the integral, apparently, right, this is very straightforward. So eventually, you will have 4 pi a square and then multiply by 2 pi a. The answer for this integral is going to be uh, mu I divided by 2a. So this is the answer. And this value should be very similar to what you can get from Ampere's law. From Ampere's law, one turns inductor will use a magnetic field B divided by mu I and then N and then divided by L. In this case, uh, N is 1, so 1 over L. If N is 1, then uh, 1 over L. And 1 over L will be the height of this coil. In this case, we don't know the height. Uh, the height is, uh, there's no height in this conducting ring. Uh, we only have 2A. Uh, so I don't know which is which, right? But, this is what you get by this Biot-Savart law. Okay, thank you.